So we go back to Avocado from the Zoom. I hope now it's okay. So as I said, we've been working on avocado fertilization for 4 years now. That's about the time that you start to realize what we know and what we don't know. Don't have yet revolutionary conclusions, but we do understand much more, and I'm happy to have the opportunity to present it here. When I said we, it's a group effort with the researchers in Gilat, Arnon, and Alon, and Or, and Chagai, and quite a lot of help from the Avocado board, Adar, Mickey, Daphna, and so on, that they're all involved. Udi Gafni, of course. They are all deeply involved in all of this. And during this time, I was got a position in the Western Galilee R&D Center to be the scientific consultant. Okay, so as I said, about 4 years ago, the growers came and say, we want to revise our fertilization recommendations. Okay. And mainly we needed to increase yield. The general pictures of the avocado is very clear. The consumption is increasing mainly due to increase in Europe, where they hardly grow avocado, but they consume more and more avocado. Most of the avocado growing is in Mexico. You can see it here, over 50% of the production, but they also have the highest consumption level, and they export mainly to the States. So Europe is not part of it. So although Israel is relatively small in area, you can see here, sorry, that Israel is a relatively large exporter, the 7th in the world in terms of ton of avocado export, and that's only to, or mainly to Europe now. And that's only Hass, or again, not only, mainly Hass. The only variety that the Europeans are interested in is the Hass, which the rough skin, black is ripe. This is what they like. This is what they want. And of course, that the Hass is the most sensitive, problematic variety that we can find. It has some kind of eject button, and every stress, it will drop the fruit, as you can see here. It's sensitive to chilling or to radiation stress. I will present it much more than the green varieties. It's sensitive to salinity. It's sensitive to drought. It's sensitive to heat waves. Everything that we have here in Israel, the Hass is not the best variety. In the green varieties, the farmers get over 2 tons per dunam or 20 tons per acre. In the Hass, the average yield across Israel is 1.3 tons per dunam. That's much, much lower than the green varieties. I think the reason, there is no one reason. There are all the reasons. It can bear 3 tons per dunam, we know that. But then the next year we'll have a heat wave in the spring, and then we'll get nothing. Also, pathogenic attack, many different. Here you can see chilling stress and the result, okay? So our general approach was, if we will feed the trees in the optimal way, we'll get stronger trees that can can face better all these stresses that we have no way to eliminate, okay? It is going to be warmer, and sometimes in the winter it's going to drop below 1 or 2 degrees, but the only way to deal with it is to create a stronger tree. That's the general idea. So 4 years ago, we initiated a couple of experiments, one in containers that you're all aware of, the way we do that with perlite, 1 cubic meter, and another one, which is pretty much the same, but in the field. We're aware that it's much longer. So just set an experiment and start creating different levels of nutrients. And after 3 years, when we had some conclusions to the farmers, we initiated a series of small-scale experiments in the north, in the Galilee. So the first experiment, the lab, is the container experiment, where we don't care what happens in the root system. We just manipulate and create trees that have wide range of nitrogen, phosphorus, potassium, and in this case also micronutrients. We want to find where the optimum is. What is the ideal tree? And we do it in tools that more resemble a lab than a field. We just irrigate it with wide range of nitrogen from 10 to 120, wide range of phosphorus, potassium, and 2 levels of micronutrients, which are all together, okay? Iron, manganese, zinc, copper, and so on. This is how it looks at the beginning. Avocado have to have pollinators, so we just planted pollinators in the soil between the rows of the Hass. In the containers, we have the variety Hass, which is the main and the most important variety. This is how the trees look like a few months ago. Okay, in the perlite, it grows fast. I think now we are at the stage that it's nearly, it looks like in the field. It can bear significant yield, which is comparable to what we have in the field. So the first indication that everything works fine is the leaf analysis. We do leaf analysis in October every year, the way the farmers does, and we see that the more nitrogen we add, the more nitrogen we find in the leaf, and we see again and again and again the saturation in high N levels, which is very important, and I will highlight it in the next slide. So if we have deficiency, we have the red line indicates the deficiency threshold. So it's below the threshold, but if we increase the nitrogen in the irrigation, we have stable levels. Phosphorus increase with the amount in the irrigation, and we have one treatment which is significantly below the deficiency threshold. Potassium, the same. We also see that the micronutrients response, we have more micro, we have more iron, we have more zinc. So everything working. Visual effect, we started to see much earlier than usual. I have to say that in general, we did the same trick with olives, almonds, pomegranates, and it takes time for trees to show deficiency. Not in the case of the avocado. Within 6 months, we see that the low N levels, 10 milligrams per liter, which is not nothing, it's quite a lot. It's, you see, it's much smaller, and it's chlorotic, and the plants, the side increases with nitrogen up to 80 milligram per liter, which is a lot. And at 120, we have more compact tree. It's very dark green. If we don't have the 80, it might look perfect, but it's much smaller. more compact, very green. The best way to monitor the tree growth is to measure the uptake. Big trees transpire more water than small trees, and they're always very well correlated. And for 4 years now, we do it in a very primitive way. We have a controller that measures the input, okay, how many liters we apply to a container in a year. And then you need a very dedicated student that come with bucket, measure the volume of the leaching, and the input minus the output, that's the evapotranspiration, okay? This is what we did for 4 years. It's quite a lot of work and requires students, which are hard to find sometimes. Now Gilat is working in Kenya, growing avocado, I think, or vegetables. So this is the second version of our evapotranspiration measurements. We have a set of valves, each connected to each container. And during the night, each valve opens, the pumps take the water into the bucket, measure the volume, discard it, and we have daily water uptake measurement per tree, 50 trees in this place. And now we have this, and we have a bucket where all the drainage come to at the same time during the day. We can even be more sophisticated and also measure the nutrients concentration. Again, so far, we manually took samples, take it to the lab, measure nitrogen, phosphorus, potassium, and we can have a mass balance. If we have this, by the way, this is a result of the hackathon that was conducted in Gilat. And we found that there are a set of electrodes with automatic calibration. So you just put the standards connected to electricity, it will calibrate itself every day. And we can measure here also the nutrient concentration on a daily basis. I think after 2 years, this information will be precious. It's not green gold, it's I don't know, other color type of gold. Okay, so this is what we got with a manual determination of uptake. It's only once in 2 weeks, roughly. You can see the water uptake of the 5 N levels during the first, the second, and the third year of the experiment. Now we are in the 4th year. It's hard to say, but remember that we started on March. So around summer, we already saw differences in water uptake, differences in size, which increased in the 2nd and the 3rd year. And what stands out is that the 80 milligram per liter transpire more water than the 40, and then the rest of the treatment. And of course, the very light yellow, that's the low nitrogen treatment. Below, you see the phosphorus and micro treatments. So for 2 years, we had no difference at all. And you can see in the 3rd year, last year, 2020, the treatments that receives more micro nutrient solutions. So instead of 0.5 milligram per liter iron, 2.5, 5 times more than the recommended. It's start to grow tremendously. Now it's the biggest trees in this experiment. Water uptake, of course, increased tremendously. And you can see here the peak of the transpiration last year, late August. And you can see that this, while most trees, let's look at the 3 potassium treatments, they all had about the same evapotranspiration of 100 liters per day, okay? And this is also what happens in the field. If we have 45 trees per dunam, so 100 liters will be 4.5 millimeters. how much the farmers irrigate in August, 5 millimeters. So it does make sense. But see, the trees that received more iron, manganese, zinc, I don't know who did the difference. They're about 30% larger, and they have 30% or even 40% higher evapotranspiration. And that's very puzzling. Potassium and phosphorus had very little effect, and nitrogen exactly the same as you see it visually. The more nitrogen we applied, the bigger the trees were, the more evapotranspiration we measured, up to 80 milligram per liter. And then we increased the N concentration just a little bit. 40 milligram per liter is not a lot. And you see this huge decrease in size and hence in the evapotranspiration. That's a huge decrease. That means that these trees are about third of the 80. And that's not toxicity, okay? 120 is not creating salinity. It's not osmotic stress. It's very clear that it's something else. And it's absolutely not clear what else. And I call it a physiological disorder, okay? And Uri Hochberg sent me a paper that was published just yesterday, a work of Avner Zilber, that showed exactly the same for mango. So see that mango with no nitrogen yield, that's the average yield of 4-year study in tzemach, okay? Yield is low, 10 milligram per liter is optimum, and 20, we also see a significant decrease in all parameters. They show in this picture that even the nitrogen uptake decreases when the nitrogen level increases. And so mango and avocado visually are very much alike in terms of response to fertilization. They are the two extremes. In nitrogen, we got the optimum, remember, here at 80 milligram per liter. In mango, 10 milligram per liter is the optimum. At 10 milligram per liter, remember here, we have a tiny yellowish tree which hardly bear fruits. So that's because the avocado is very vigorous and mango is the exact opposite. Okay, so what I'm trying to say, and we also have the same data from olives and almonds, that for nitrogen only, if you apply excessive amount, and what is excessive, who knows, you have very quickly a sharp decrease in all performance. Even the nitrogen uptake decrease compared to the optimal level. And that's, of course, have also environmental impact. And that's something that we are very interested in, because it repeated for all the trees, the fruit trees species that we tested. And we started a side project with Moshe Alperin, that is here, to see what is the cause, that's the first, to this decrease in response to nitrogen over fertilization. And maybe we will be able to come with better indication, not leaf analysis, that's not relevant, to identify over fertilization with nitrogen. What's the problem? We use the young avocado and almond trees, and we applied low, medium, and high nitrogen level. And you can see after 2 months, you don't see any effect visually. You see that at the high and low end level, evapotranspiration decreases. We have some kind of something bad happening, but we don't know yet what it is. And after 6 months, you can visually see the low nitrogen, which is the optimal for mango, is small and yellowish. And the high nitrogen, exactly as I showed earlier, is green, but small and condensed. But when we do leaf analysis, we can identify the deficiency we cannot identify the excess of nitrogen. It's just reach saturation. This is optimal, this is excessive, and total N is similar. And what we did with Or and Hagai and Moshe, we simply scanned all the metabolites that we found in leaves and branches at different nitrogen levels and look for indicators that do respond to nitrogen over fertilization. And you can see here an example that some very basic amino acids like the serine, the glutamic acid, alanine, they do respond to nitrogen in a continuous way, unlike the total N. And we have some additional indicators that we think might have a potential, but we just need to collect more data, much more data. And I think one of the greatest challenges is if we'll find one for avocado, it's not enough. I want to find an indicator that will be similar to many fruit trees and can be used for more than just one species. We had an hypothesis that nitrogen over fertilization affect root growth, actually impairs root growth. We know that under nitrogen deficiency, all plants, including fruit trees, develop much denser and bigger root system. So we tried to extrapolate and said, okay, so maybe if we have too much nitrogen, the root system will be smaller, and that's the reason that the plant cannot grow properly. So Moshe did quite a lot of work with these trees, harvesting, measuring the root area, and we found no effect of nitrogen over fertilization on the root system. It was actually the same as the optimal. So remember, the shoot was decreased, but root system looks great. And I think at this stage, we rolled out this hypothesis. I've mentioned earlier that we are doing mass balance not only for water, but also for nutrients. If I know the concentration in the irrigation solution and we collect the solution in the drainage, we can know if we applied 4 grams of nitrogen in a day and found 1 in the drainage, then the tree took up 3 grams of nitrogen. In this figure, I don't present the uptake, but rather the concentration in the drainage. We try to maintain a fixed concentration of 30% of the irrigation. And we see very interesting annual dynamic of the concentration in the drainage. In the mid-season, June, July, August, we have high concentration in the drainage. Then it's decreasing from November, December. It's very low at the end of the winter, nearly 0. You see quite a lot of measurements where we found no nitrogen in the drainage, and then increase again in the spring, decrease again in the winter, increase again in the spring. So I think here what the tree is trying to tell us, we don't have enough nitrogen in the winter, we have more than enough in the summer, we don't have enough in the winter, and so on and so on. This is something that you cannot really do in the field. It's nearly impossible. It does, in good agreement with what Avner said for a very, very long time. You have to apply fertilizer throughout the year, but Avner never showed this very clear empirical evidence that the plants uptake substantial amount of nutrients in the winter. I was very surprised. I told the student immediately, let's have thermometers in the perlite, in the root system, and see how it is compared to the soil. And it was very much the same. The only difference is that you can sense the irrigation in the pot, but not in soil. temperatures are low, around 12 Celsius in the winter. Sorry. And still, N uptake is very intense in winter. Or Sperling, my neighbor and colleague in Gilat, found it very interesting. He took the data from almond that he collected, to the data from pomegranate, the project of Arnon Dag, and said, let's try to make sense of this huge amount of data that you collected from the drainage. If high in the drainage, high levels indicate excessive application, and low level means low amount or deficient concentration, let's try to do some kind of computational approach to see what's the optimal concentration for different plant species at different physiological stages, okay, or phenological stages. And you can see here with the almond, the red line is the nitrogen, phosphorus, and potassium that were applied in the irrigation. And the blue dots, that's the measurements in the drainage. And you can see in general that they always applied too much nitrogen, phosphorus, and potassium. And therefore, the concentration in the drainage is consistently higher than the irrigation, except at a certain stage of time, which make sense when you look at the phenology of the almonds, where just finished to develop the leaf and then requirements are higher. You see the avocado, this is what I presented earlier, it has very, very clear annual pattern where concentration low in the winter, high in the summer, for nitrogen, for phosphorus. That's not the case for potassium, where most of the year we applied too much potassium, and therefore we got concentration which is too high. And what he did is simply plotted this response of the concentration in the irrigation versus the concentration in the drainage. He used a second degree polynomial to fit to this association, okay? And then measured the place where we believe that's the optimal concentration, where the concentration in the drainage is similar to the concentration in the irrigation. What's this point indicate? It means that the tree took up water in the same proportion as nutrient. If we have concentration that is higher than irrigation, that means that the plant took up more water than nutrient, and vice versa. Here it means hunger, here it means excessive amount, and he did this for the three plant species and came out with actual recommendation according to phenological stages of what is the optimal concentration of nitrogen, phosphorus, potassium for avocado, almond, and pomegranate to find this very balanced fertilization. So this is very interesting approach that can be used only in this unique system. Let's go back to the negative effect of nitrogen over fertilization. I would expect that nitrogen over fertilization, since we have smaller trees, very compact and seems to be stressed, that the photosynthetic system will also be impaired, will be damaged, and we measure it every month. So 3 years, that's quite a lot of measurement. I just gave here an example. There's no negative effect of nitrogen over fertilization on assimilation rate. There's even something that looks like a positive effect. There's a slight decrease in the stomatal conductance, but that's not the case. Nitrogen over fertilization does not have any negative impact on the photosynthetic system, which is the engine of every plant. So assimilation is good, and that's interesting and disappointing at the same time. We did see a very unique annual dynamic of assimilation rate. You see the 3 years of study. Every year we have high assimilation rate in the summer, and from September, October, we see a very noticeable decrease in assimilation rate. And to me, it seems more than anything else that the avocado suffers very much from low temperature. That's not, avocado is originally from Mexico, from more temperate climate. It's not, cannot tolerate low temperature. And we measure the effect of low temperature on photosynthetic system, or the, I would say, FV to FM indicates photoinhibition or damage to the photosynthetic system. Okay, so as long as this value is above the green line, it means that it's okay. And you see that regardless of the N level, during most of the season, we have good FV to FM values. Starting from November, we have sharp decrease and then recovery. That was 2 years ago and last year, and we see that only in mid winter, the nitrogen level does affect the photo damage or photo inhibition, okay? And we see that the plants that are starved for nitrogen have the lowest decrease in FV to FM, and we constantly see that this N80, 80 milligram per liter, which seems quite a lot to everyone that's familiar with fertilization, that's a lot. And it's always optimal. And we have more indications, which I don't present here, that we see that nitrogen fertilization increase the ability of the plants to deal with this excess of radiation. Cold temperature, the combination of cold temperature and high radiation, which is very typical to Israeli winter and in the Negev especially, is devastating for the photosynthetic system. That's what you see here. So high nitrogen level allows better recovery or better. This year we had very cold temperature in late January. You can see that the damage on new growth. You can see very severe damage in trees that were not harvested at this time. That's the mid-season. So half of the trees were harvested and half not. And you can see this, you can actually see the photo damage on leaves that are facing south and that are exposed to very high radiation after a night with very cold temperature. Okay. Nitrogen also had increased the development of flowering buds. You can see here that at early stage in winter, we see very developed flowering buds in the high nitrogen level, but not in 40. And the next year, we'll skip that. So far regarding yield, we don't have much luck. And you can see here that that's in general the story of the avocado. Now in April, we had fantastic fruit set. You see each flowering branch had 20 or so fruitlets, and it all dropped on June. And that's very typical to avocado. We don't really understand whether it's the temperature or so on. We see an effect of treatments, but eventually when I have 3 or 4 kilograms per tree, it's not something that I can conclude anything about. Okay, and this is what we see in June. We hope, and that's what Daphna works in Sham, and she's my guide for avocado. She said that's very typical for young trees. We hope that in this June, in a month, we'll have significant fruit set and yield, and we don't see this sad picture again. Although we had very little amount of fruit, we can characterize the fruits, okay? I'm not saying the yield is important because 2 or 3 kilograms is relevant, but we see an effect on fruit size, and that's very important. We want fruit that is about 200 grams per unit, and we see again, increase with nitrogen and then decrease, exactly like everything else. And again, the N80 seems to be optimal. We see that phosphorus deficiency had very pronounced effect of the shape. All the low P fruits were very rounded, while the rest of the fruit looks like a typical pear shape, like the Hass avocado is. And that's also significant. In the past couple of years, the exporters, or well, mainly the consumers, complained on what is called internal decay or internal brown, yeah. And we decided that in this year with very low yield, we'll start, we work with the Noam Alkan from the storage department and try to see if we see any effect. Ishai is the student that's working on this subject currently. And what Noam is claiming for the past year, that calcium is very important to preserve good quality avocado. And in his experiment, when he applied post-harvest, when he applied calcium to the fruit, he got longer shelf life and less internal browning, okay? And we know that it's the same for the blossom endrot, the bitter pit, the jelly seed in mango. It's all the same, and in my lab, we work on this subject extensively, using polyphosphate as chelide for potassium. You can see here, for example, in potato, the x-axis is the tuber calcium concentration and the amount of bruises, these dark spots you all know if you ever peeled potato. And you see that those bruises decrease when calcium increases, okay? So it's a well-known fact that calcium has a good effect on the storage life. We don't have a treatment with calcium. We do have treatments with which we manipulated nitrogen level. This is from the field experiment in Kfar Menachem. We have 4 nitrogen treatments, no 20 kilogram per dunam and 60 kilogram per dunam. You have quite a lot of nitrogen in the wastewater that they irrigate with. And you see this U-shape effect of internal browning and nitrogen. Low nitrogen and high nitrogen both have negative effect. So until I saw these results from Noam, this is the work of Noam, which is an expert, I was very insecure about the results that we collected. I said, just do it to exercise, but we found exactly the same. When the trees were starved, we had very high effect. At optimal N levels, we got nearly optimal fruit quality. And again, an excessive amount of nitrogen really promoted the appearance of this browning. So that's very interesting. We're trying to analyze calcium now in fruit just to see if there's any association. There's not much knowledge on avocado plenty on other fruit trees and vegetables, of course. Nothing about avocado. And also the farmer said that it could be a couple of years with no post-harvest damage, and 1 year it's catastrophic. So it's probably not only one, for sure it's not only nutrition. Maybe other environmental effects play a role. כמה זמן יש לי? Okay. We found a very interesting response to phosphorus in the container experiment, which we don't know what it is, but it's a dieback. That's what we see. Dieback of flowers in response to phosphorus. The more phosphorus we found, the more of this dieback we found. It looks very much like Botryospermia, very famous disease in avocado. And we have a world expert on Botryospermia here in Vulcano. So I send these branches to Danny Steinberg, and he concluded that there's no Botryospermia in these branches. I see many things. It's not Botryospermia. So we don't know what it is. It might not be pathogenic at all. It might be some kind of physiological disorder. Other physiological disorder, I don't know. I really don't know. The thing is that the trees look great until flowering, and then the flowers just die. And that's very interesting. And it's well correlate with the little fruit set that we did find. So the highest fruit set was in response to the lowest phosphorus. And currently we honestly don't understand what it is. And I just hope it will disappear. That's closing my eyes. Okay, in the field, we have a comparable experiment with 3 levels of nitrogen. You saw it already. So in this, it's in Kfar Menachem. The wastewater from the Sorek wastewater treatment plant. So we have about 20 milligram per liter of nitrogen, and on other levels, we have about 2.5 milligram per liter of phosphorus, and that's with phosphorus, and we have about 20 milligram per liter of potassium, and we add to that, okay? The alternate bearing in this site is very extreme. You can see here on, off, very typical to avocado, but it's also management. And just to summarize the first 3 years, we didn't see yet an effect on nitrogen or potassium or micro. We did see a positive effect, which is significant, although surprising, to phosphorus. Actually, farmers do not apply phosphorus when you have the right concentration in the leaf analysis and when they irrigate with wastewater that does contain phosphorus. But okay, this is what we found. In the north, after we found out that the uptake of nitrogen in the winter is substantial, we initiated 3 experiments. One in the Western Galilee farm, large plot, 30 dunam, with and without application of nitrogen in the winter. The Shanim company initiated another experiment where they are testing different type of nitrogen in the winter. So one is the most common and simple, very high nitrogen level, so very simple to apply. You have to understand that farmers do not use to irrigate in the winter. In many places, the irrigation system is not working. It's time for maintenance. So how do we apply nitrogen when the orchard is three different types of nitrogen with and without nitrification inhibitor. It doesn't really matter the treatment. Overall, after 2 years, we see a significant increase in yield. So it's a 280 kilogram per dunam increase in yield in the plants that received nitrogen in the winter compared to the control. In many terms, the growers go faster than we do. And now in the Western Galilee, now it's the practice. When we started, I said control, no application of nitrogen in the winter. I would say, but that's not the control. We all apply nitrogen in the winter because you said it and Avner said it, so we do it. But that's still very far from the global practice. Okay. Sorry, I have a slide missing. Also, Haifa doing the same thing, but Haifa is the control released fertilizers. So they apply this granule that can supply nitrogen throughout the winter without the need to apply it through the irrigation system. So that's their solution. They test it. So far, we don't have any result. So that's it. To summarize, we saw that avocado is very unique. It has a huge demand for nitrogen. We see in the pot experiment that the optimum was at 80 milligram per liter, whereas most fruit trees are between 10 mango to 20 olives or 25 for almonds. And this is very unique. Grow like a weed more than a tree. But over application of nitrogen have very significant negative impact on everything. Development, the little yield parameters that we tested, and post-harvest properties. And we need to know how to identify this negative impact of an over-fertilization, how to find it in the field. Yeah, that's the main messages. That's as I said at the beginning, it's a collective work with many colleagues, and most of the technical work was done by the student Gilat that graduated his master and now working in Kenya. My team, Jonathan and Adi, Daphna from Sham, and now the students in this different project are Ishai for the control experiment, Gal in the field experiment, and Nadav. And we got funding from the Avocado board, which is very exceptionally cooperative and very, very nice to work with these guys. The chief of science, and of course, ICL, CFPN, when the funding from chief of science ended, they assist us very much. Yeah, that's mainly, of course, we have all the group in Gilat collaborating, and Noam from here and many others. That's it.
Thanks. Oh, nice. How should we do? So we have some questions here, and I will just tell the audience, the Zoom audience, if they want to ask, they can put it on the chat box. You already have one question in the chat box. It was from earlier. Maybe you can start with that. Are leaves of high-end plant thicker?
Not that I can see with my bare eyes. The question was, are the leaves of high-end treatments are thicker? Not that I can see. Shoot is shorter. That's true. Everything is more compact. We call it the cauliflower trees. It looks like a cauliflower, just compact. One of the Woody Gaffney, the head of the Avocado board, said that, well, maybe that's the optimal you said it's damage. For me, it's great. It's a tree that you don't need to harvest much. You don't need to irrigate much, but it has very intensive flowering because if you have very short, so you have more flowers. Each leaves bear one flowering bud. Yeah, that's what we see. We don't know exactly what it is. Regarding fruit, as I said in the controlled experiment, nothing that we can count on, okay? But trees that are third of the size of the optimal tree cannot bear 80 kilograms per tree. It's simply too compact. So we need that the first 3 years, we need to have large trees with thick and heavy limbs, branches that can bear 80 kilograms per tree. So, and maybe the recommendation for fertilization should be different for the first 3 years and later in the orchard life. Okay.
Maybe some questions coming.
Yeah.
Thank you, for your lecture. Full question, but I admit that actually I'm fully ignorant about that. I understood that you don't exactly know why there is option, why there is decrease in damaging effect high nitrogen concentration. My question is, I guess that nitrogen fertilization is for hundreds of years in agriculture. So what is it now for any kind of the culture, for any fruit or something? I mean, do we have any analogy, even far analogy for that?
Yeah. There are different hypotheses for different species. We see exactly the same for sesame, for example. That is, it's very different annual crop. A lot of time in the literature, they just say it promote vigor on the response of yield. Now, that's not the case, but this is how they dismiss this decrease in yield with higher nitrogen. Honestly, I think we don't really understand. Maybe wheat, maize, and soybeans and rice not responsive to that. So that's 80% of the studies related to nitrogen. Moshe, you have an idea? But do you have an idea why? You worked on nitrogen for many years. Imbalance, yeah, that's the yeah, it's nothing. It's a way to say we don't know.
But even I would say if it is well known, that might be optimal or not, because maybe that's very general phenomenon now would be destroyed that we didn't see or we're not convinced, or still there is a known phenomenon but there is no explanation.
I think it's yeah, option B. I wouldn't even say it's a well known. It is repeatedly when you study, you see, and it's very unique for nitrogen. It's not the case for phosphorus or potassium. You see this decrease. It's repeatedly reported, and I think it's far from being understood. We had two hypotheses. One is that nitrogen over fertilization will impair root development, and it doesn't seem to be the case. We also thought that it will have some kind of negative impact on the photosynthetic system, and it's absolutely not the case. Maybe later, after the damage is done, no, it's the consequence and not the cause. Again, if I'm not an ecologist, but if you think evolutionary perspective, plants were never expressed to high-end values. They might be not selective to nitrogen. That's it. they develop in place where there's not enough nitrogen, maybe excess of salts, of sodium, chloride, and so on, but not nitrogen. This is something that is only in the recent years. And maybe they don't know how to shut it down. And then excess of nitrogen, again, it's a metabolic issue, creates some kind of metabolic misbalance. Bear in mind, for example, that to assimilate nitrate, the plants have to do it fast. They need to reduce it to ammonia. They need carbon to assimilate the nitrogen and store it somewhere. It has costs of energy and carbon. And that, again, I'm just hand waving. I don't know. Okay.
Noticed it in the winter. I think it was very nice. In the winter, there was a range of trees. The trees from the response. Some trees completely below and some high. So the range is very high in the winter. The nitrogen content showed. So that means that some trees are more responsive than others.
Yeah, but what you see in the figure, it's an individual tree. When you do average, then that's what OR did. It looks more, smooth.
The tree level. So
Yeah.
is there, differential response of every tree, and then is it possible to know in real time what is the nitrogen demand of each tree? So I see you have a project with Erel. Maybe
Yeah.
that's where it's going.
That's very interesting comment, because avocado is also unique by having the highest variability that I've ever seen, and that's where we just got a grant with Tarin to try to map, has the highest variability in any term, in growth, in production, in nutrient uptake. And at the beginning we said, okay, we use the rootstock is seedling, but now you can find in the market vegetative clones where the rootstock is uniform, and we still see it everywhere. And that's very interesting. I have no idea whatsoever. All the experts of avocado said, well, that's avocado. When we selected the site, so you see a large tree, small tree, a missing tree, and a yellow tree, green tree, in all the lines. Okay, I cannot do experiment here. You have to work with olives, which are very uniform. And I said, Ron, this is one of the best orchards, most uniform orchards that we have. It's an excellent farmer. In every when they plant the avocado, they have about 10%. You need to fill it up. It's terrible in terms of uniformity. Variability is huge. We monitor the trees. We have trees that give 70 kilograms per year, average on 4 years. We have trees that give 10, and they all look the same. They look exactly the same. We have no idea. Of course, the tree that bears 70 kilograms per year for 4 years have much higher demand for nitrogen, for example, than the other one. So variability is a huge challenge.
One reason is that they should be planted in Mexico. Seriously,
Is it also like that in Mexico, the variability?
Not that I know. It's very different.
Very different with very big roots.
Yeah, but they flower all year around. They produce fruits all year round. Of course, that's suitable for tropical climate.
Thanks.
Okay, thanks.
תודה. חג שמח.
חג שמח.
ביי זום.